Hello everyone, my name is Trihil Sukolov and I would like to present our paper on the technique for storing and automated processing of weather station data in cloud platforms to the International Scientific Conference of Communications, Information, Electronic and Energy Systems. My co-authors are Stefan Vlaev and Mikhail Cheleshkov. The contents of today's presentations are introduction, description of the proposed cloud architecture, deep neural networks that have been used in one of the components. Then I would like to present the results and discuss them. Then the presentation contains the references and acknowledgement for this paper. All of us are researchers at the University of Telecommunications and Post in Sofia, Bulgaria, at the Department of Information Technologies. My personal areas of research are biometrics and neural networks. My colleague Stefan Vlaev is based in the software-defined storage and cloud technologies. And our colleague Mikhail Cheleshkov is working on performance optimization, data mining, and pattern recognition. With the introduction of today's paper, I would like to say that there are many sensor technologies in the IoT field. Each of them is network capable and able to deliver data to a known recipient. This leads usually to a huge storage expansion. In the cloud space, there is an opportunity for dynamic storage expansion and processing, which can be used to cope with this kind of problem. Also, the availability of multiple sensors are the key enablers for the big data and knowledge extraction technologies in the field of machine learning. Our previous research involves multimodal biometrics. We have been involved in ECG and EEG analysis and human-computer interface. We have also experience with face recognition and identification. We have also worked on skin color detection in images. In the field of cloud technologies, we have worked on cloud architecture for systems in the educational field, and we're also working on biomedical data analysis. The opportunities for this research in the field of weather station data processing, we are seeing in the abundance of digitized sensor data, we are still seeing a serious lack of process automation in this field, and there are many cases of underused resources, including cloud and on-premise resources. There are also many available tools and methods for automated analysis provided by AI and machine learning frameworks and platforms. And also, we see an opportunity here for the ability to make multidisciplinary research. Next, I would like to talk about the architecture that we have proposed. As we can see, there are weather stations situated all over the globe, which can send their data over the internet to some kind of recipient. Our architecture uses this feature, this opportunity, and involves multiple, and is able to receive multiple weather stations data over the internet. This data is transmitted to a load balancer, which is able to dispatch the data to a proper recipient. Then the data is received by the Docker containers, which are specialized in various areas of the data processing. Also, the Docker containers are connected to the persistent storage so that the data can be stored for the future purposes. Our data source is presented by Atmos 41. This is a device with several measurements provided by a private company. The measurements from the data source are received at 30-minute intervals. The cloud service containers are specialized at one point for the deep, long, short-term memory neural networks that we have used, and they are namely processing the time series. Also, we have a presentation layer, again realized in containers with the software called Grafana. Our load balancer is using HA proxy, which is a high availability proxy, a well-known software for achieving reliable load balancing. The container management system that underlies this architecture is Kubernetes. But please note, this it will be part of our future research to show that there are other opportunities besides Kubernetes. The persistent storage layer is realized with Ceph object storage, which is also a well-known software for object storage. The long short-term neural network. It is a building block for the recurrent neural networks. It is able to process input data and provide forecasts for the future states. It is also applicable to nonlinear time series prediction. And one of the capabilities that we find especially useful is for handling missing data and long-time dependencies. This is very useful for the weather stations, since some of them may miss sending the data over to our system, which in the end will not negatively affect the prediction of the results. On the next slide, I would like to show that we have provided some experiments on deploying this architecture, this solution to a container-based infrastructure, and we have compared the results to the deployment on virtual machines. As can be seen, there is a speed up of at least 2, and this shows that this system is especially designed for container-based application. Since the containers are usually faster than virtual machines, we have chosen this type of model to work with. Our ongoing experiments are involving populating sensor data. We would like to involve multiple sensors and check how the system will behave. We're training our LSTM deep neural network for predicting the historical measurements, and we're preparing an algorithm for detecting anomalous activities and events such as fires, storms, and proximity alerts. This paper has been sponsored by an internal grant of the University of Telecommunications in Post for implementing and adopting cloud services in the teaching process. Here are the references that are used in this paper. And with this, I would like to thank you for your attention. To wish you all the best of luck and health to you and your families, and to thank the organizers for this wonderful conference in difficult times. Thank you very much.